Very good morning to all of you. So, dear students, today we will keep continue of the IUPAC nomenclature of the carboxylic acids. So, according to new IUPAC recommendation in 1993, when there are two or more carboxylic groups attached to the main chain, for example, here there are there are three carboxylic groups attached to this main chain. So the name specs to name secondary specs is replaced by carboxylic acid. So instead of using the oic acid, we will use the name secondary specs as carboxylic acids. And also these carboxylic acid groups are not included in the main chain. Clear? So name of the compound will be, when there are three carboxylic groups attached to the main chain, so they are not included in the main principal chain. So numbering will be start from this carbon, first, second, and third. Clearly, so accordingly you write the name of the compound. First, there are no any prefix. So there is no any substituent. So you will start the naming of the compound by from word root plus primary suffix plus secondary suffix. The word root is actually how many in main chain, how many number of carbon atoms are here. There are three. So you will write the prop. You will write the prop. Clear? After that, what is the secondary primary suffix? Word root what is the primary suffix here? The primary suffix is carbon single bond. That is primary suffix N. So that is propane. After that, you will write the secondary suffix. So secondary suffix here is not oic acid, but it is carboxylic acid. So carboxylic acid is a secondary suffix. So how many carboxylic acid groups are there? There are three. So you write the tricarboxylic acid. So you will also indicate the position of these carboxylic groups. So is 1, 2, and 3. So you write the propane 1, 2, 3 tricarboxylic acid. So accordingly you will write the name of the molecule. So name of the molecule is propane 1, 2, 3 tricarboxylic acids. So you must remember that these are not included in the main chain when there are three carboxylic acid groups attached to the attached to the main chain, principal chain. Similarly, but in this case, when in some cases the molecule, this carboxylic group, third carboxylic group, is not attached to the main chain, but it is attached to the side chain here. For example, you are seeing here there is a the chain is there is a side chain here. So as a result, this carboxylic group is not now attached to this main chain, because the main chain is the one which is the longest and which contain more functional groups. So here main chain will be 1, 2, and 3, 4. Clear? This will be selected as the longest chain, and that's the principal chain. So when we write the name of the compound, so you will take these, the COH group which is attached to this side chain, it is taken as prefix now here, according to old IUPAC system. So you will take it as a prefix, then write the name of the compound as usual. So this is when we give the numbering, it's at third position here. So that at third position it will be the carboxyl methyl. So at third position there will be 3 carboxy methyl, 3 carboxy methyl, and rest is word root pent and primary suffix N. And there are how many remains carboxylic acid groups? 2. So this is dioic acid is as usual, which we were using previously in older system. Clear? So accordingly name of the compound will be 3-carboxymethyl pentane dioic acid. Clear? Similarly, in case of aromatic acids, now aromatic acid is when the carboxylic group is carboxylic group is attached to this benzoic acid. Clear? So it is attached to this benzene, so then it is called as a benzoic acid. Similarly, when it attached to when some other substituents attached to this benzoic acid, then these are derivatives of actually benzoic acid. So this is present at first position, this second position. The name of the compound will be 2-methyl benzoic acid, or it will be also named as, this is ortho to this carboxylic acid group. The name will be orthomethyl benzoic acid. Clear? So orthomethyl benzoic acid, or 2-methyl benzoic acid, or it is also named as orthotulic acid, because this is actually toluene. When only CH3 is attached to this, when some other group is attached at ortho to this methyl, then it is named as orthotulic acid. Clear? Similarly, so here is one of the another molecule here. So it is a 2-hydroxybenzoic acid, because hydroxy group is present at second position. So it is 2-hydroxybenzoic acid, or it is ortho. It may be also orthohydroxybenzoic acid. You may write the name orthohydroxybenzoic acid, or it is named as salicylic acid, formed during that Raman-Diamond reaction when phenol is treated with carbon tetrachloride. Clear? So this is all about this. So there are some other molecules, some dicarboxylic acids. When two carboxylic acid groups are attached to this benzene ring, so you will write the name benzene 1,2-dicarboxylic acid. Similarly, when this is attached at third position, you write the 1,3 benzene 1,3-dicarboxylic acid, or they are commonly named as phthalic acid, and this is named as isophthalic acid. Clear? So similarly, when there are three carboxylic acid groups attached to this, three carboxylic acid groups present, so this is one of the molecule, one of the compound, and there are three carboxylic acid groups. So they are commonly named as econitric acid. Clear? Though there are actually carbon double bond 1, and there's one CH2 group, and there are three C double bond COH groups, and it means that there are three carboxylic acid groups. So accordingly, you will see here that there are three carboxylic acid groups. So this is called as a citric acid. Citric acid, the formula and the structure of the molecule is here. So it is actually there are three carboxylic acid groups attached. So there are also two methyl groups and one hydroxy group. So you will remember the structure of the molecule, and this is called as a citric acid present in the lemon. Similarly, so we will discuss the structure of carboxylic acid, or you may say the nature of the carboxylic group. Actually, the carboxylic group actually consists of two things. One is carbonyl group, and one is hydroxyl group. And we have already discussed that carboxylic acids are actually made combination of two groups. One is carbonyl group and one is hydroxyl group. Clear? So accordingly, when we see this carbon atom, we know that when carbon atom is having double bond, so it is sp2 hybridization. The hybridization of the carbon is sp2. Oxygen is also sp2 hybridized. This is also sp2 hybridized. This group may be sp3 or s5. For example, if it is hydrogen here present, then this is s hybridized orbital. But if this is CH3, sorry, this is CH3, then this carbon is sp3 hybridized. Clear? You must have learned in hybridization process, because carbon forms here 4 covalent bond. That is why it is here it is sp3 hybridized. You must remember that if carbon is having single bonds, so carbon is present in carbon will have hybridization of sp3. When carbon is formed to double bond, so then carbon atom will be sp2 hybridized. Similarly, when carbon will form triple bond, so then the carbon atom will be sp hybridized. Clear? So you must remember here that. So accordingly, you will see here that by seeing the orbital picture of the carboxylic group, you will see here that this carbon is sp2 hybridized, this is sp, and this may be s or s hybridized orbital, s hybridized group, or sp3 hybridized group. Clear? So accordingly it is planar in nature. Carboxylic acids जो actually are planar in nature. So each carbon atom will form 3 sigma bonds, one with this oxygen, one with this oxygen, and one with this methyl group. For example, if we take methyl group as a substituent here, so this the carbonyl group sp2 hybridized carbon will form 3 sigma bonds. Clear? And it also forms one pi bond, but these sigma bonds are formed by sp2. This is formed by sp2, this is sp2, and this is sp2, this is also sp2, and this is sp3. So this overlapping of this one sigma bond will be formed by sp2 overlapping, that is actual overlapping of sp2 orbital, hybridized orbital, sp2 hybridized orbital, and this is sp2 hybridized, this is also sp2 hybridized orbital overlapping, but this will be the sp2 hybridized orbital overlaps with this sp3 hybridized orbital of the this carbon atom. Clear? So accordingly you will see there is a formation of 3 sigma bonds. So carbon will form 3 sigma bonds having bond angle of 120 degree. Clear? Similarly, but carbon also forms one pi bond. Sigma bonds are formed by head-to-head collision. That is, when orbital, say orbital picture, when there are p orbitals. So p orbitals are dumbbell shape. When they overlap. When they form the sigma bond is formed by the head-to-head overlapping of the orbitals. This is sigma bond formation, or any sigma bond formation. So when this sigma bond formation occurs, there occurs a head-to-head collision of head-to-head overlapping of the orbitals. But when their pi bond is formed, the pi bond is formed by unhybridized orbital, which does not taking part in hybridization. So these unhybridized orbitals remain perpendicular to these hybridized orbitals. So they will overlap sidewise. This is a formation of one pi bond. One pi bond is formed by sidewise overlapping above and below the plane. Accordingly, they will form the one pi bond. Similarly, when there are two pi bonds formed, then two orbitals will overlap above the plane and below the plane. Clearly, so this is pi bond is formed by sidewise overlapping. That is why it is a weak bond. This sigma bond is formed by head-to-head overlapping. That is why it is called as it is strong bond as compared to this pi bond. So let us see here the picture of the orbital picture of this molecule. So if you are seeing here this carbon atom forms 3 sigma bonds with this oxygen atom. One with this oxygen, second, and this there will be carbon here. Clear? So the bond angle is 120 degree. Clear? So this carbon out of the four hybrid orbitals, so 3 hybrid orbitals result in the formation of 3 sigma bonds. But there remain one unhybridized orbital. Here it is a unhybridized orbital. This is unhybridized orbital. So this unhybridized orbital will overlap the unhybridized orbital of this oxygen and this oxygen by sidewise overlapping. When this overlapping occurs sidewise, as a result of this, there occur the formation of pi bond. Clear? So this is the picture, this is the orbital picture of carboxylic group. Clear? Similarly, if you see the carboxylic group, it is resonance stabilized. How? Because if this is a R group here, there is one of double bond, and this is single bond with hydroxyl group. So there are lone pair of electrons on this oxygen. There are also two lone pair of electrons present on this oxygen. So these lone pair of electrons get shifted from here, and this pi bond gets shifted from here. So accordingly, you will see that this gets resonance stabilized. But after the loss of proton, because carboxylic acids are they are known as acids because they give proton in the solution. Accordingly, when this R C double bond OH, when this gives proton in the solution plus H positive, so what will the here remaining structure is like that. So this now contain negative charge. So this is more resonance stable. Actually, there occur a shifting of this pi, this negative charge here, and there occur shifting of this pi bond to this oxygen atom. As a result of it, due to this resonance between these resonance of the pi electron between oxygen, carbon, and oxygen. So as a result, it gets more stabilized. When it gets more stabilized, so it is more acidic. Clear? So it is actually the conjugated base. Clear? So more the conjugated, more is the stability of conjugate. Weaker the base, stronger is the acid. So this is a conjugate base of the acid. This is weak, and more will be the stronger will be the acid. So actually it is actually resonance stabilized. So this is resonance stabilized form of the carboxylic acid. So this was all about the nomenclature, and we have taken all the three forms: monocarboxylic acid, dicarboxylic acid, and tricarboxylic acid, aromatic as well as aliphatic, and in concentration in both the lectures. So this was all about this topic. Stay blessed. Have a nice day.